In this video, I will talk about how to calculate sample size. So we will discuss how to calculate the sample size for the mean and for the proportion. The required sample size can be found to reach a desired margin of error, which is denoted by the letter E, with a specified level of confidence, which is 1 minus alpha. The margin of error is also called the sampling error, and is the amount of imprecision in the estimate of the population parameter. It's also the amount added and subtracted to the point estimate to form the confidence interval. So if you recall, the confidence interval for a mean is x bar plus or minus your z value times sigma divided by the square root of n. The stuff that you see after the plus minus sign is your sampling error, or it's also called your margin of error. So we're going to take that part of the formula and we are going to solve for n. Once we solve for n, we get z squared times sigma squared divided by e squared. And that will be how you would determine the sample size for the mean. To determine the required sample size for the mean, you must know the desired level of confidence. Once again, that's 1 minus alpha. This determines the critical value for z, the acceptable sampling error E, and the standard deviation. So let's look at an example. The population of download times for a particular video file has a standard deviation of 25 seconds. If a random sample is taken, what sample size is needed to estimate mu within 5 seconds with 95% confidence? So since we are dealing with a 95% confidence, our z value will be 1.96. They told us that our standard deviation is 25. And they told us that our E is within 5 seconds. So your E is 5. So we're going to plug our numbers back in and we get 96.04. You always round up. So this rounds up to 97. A lot of students get this confused because when they see 96.04, they think they need to round to the nearest whole number. That is not the case when it comes to sample size. It has to round up. So make sure you round up to 97. If unknown, sigma can be estimated when using the required sample size formula. We can use a value for sigma that is expected to be at least as large as the true standard deviation. We can select a pilot sample and estimate sigma with the sample standard deviation of S. So I'm going to show you how you can calculate sample size using StatCrunch, and I also have a template for it. So let's go ahead and go to StatCrunch, and we are going to go to Stat, Z-Stats, one sample, and if you go 3 down, you'll see Power Sample Size. We're going to click where it says Confidence Interval Width, and we're going to plug in our information. We know we want to compute at a confidence level of 95%. They told us the standard deviation is 25. The tricky part here is the width. If we go back to the problem, it told us within 5 seconds. Okay, so that means we can go above 5 or we can go below 5. Above and below 5 will give us a width of 10. So what you're going to do is you're going to double this number here. So it'll be 5 times 2, which is 10. So I'm going to plug that into my StatCrunch. This will be 10. And I'm going to hit compute. And as you can see, the sample size pops up in the box. I also have a template for this. In my template, you have to type in your confidence level, which is 95%. We're going to write it as a decimal. They told us the standard deviation is 25. But the way I have my template set up, you only have to type in the number that comes after within. So in our problem, it said within 5. So you don't have to double this number. You can type 5 or you can type -5. It doesn't matter. And as you can see in this yellow box, your population size or your sample size will come up, and it is 96.0365, you round up, that would be 97. Okay, so now let's talk about how to determine the sample size for the proportion. So the sampling error, or the margin of error, in the confidence interval for the proportion is z times the square root of pi times 1 minus pi all over n. We're going to solve for n, and we get z squared times pi times 1 minus pi all over e squared. So once again, to determine the sample size for the proportion, you must know the desired level of confidence, when that determines the critical value, the acceptable sampling error, and the true proportion of events of interest, which is pi. Pi can be estimated with a pilot sample if necessary, or you can also use 0.5 as an estimate of pi. So in this example, it says how large a sample would be necessary to estimate the true proportion of sales invoices containing errors in a large population within 7% with 95% confidence. Assume a pilot sample yields p equal to 0.05. Okay, so since we're doing a 95% confidence, our z will be 1.96. The problem said that it wanted to be within 7%. So you need to change this 7% to a decimal. So that will be our E, 0.07, and we use P as 0.15. We're going to plug all our numbers back in for N, and as you can see, we get 99.96. We're going to round this up to 100. So we're going to use this same information, and we are going to do this in StatCrunch. So this time we're going to go to Stat, Proportion Stat, One Sample, and then Power Sample Size. I'm going to click where it says Confidence Interval Width, and we're going to type in our information. Our confidence level is 95% or 0.95. The target population was 0.15. And if we go back to the problem, it said 7%. So be careful here because we got to change this to a decimal, and it says above 7%, below 7%. So you can go up 7%, below 7%. So we're going to double that number, and that's going to give me my width. That gives me 0.14. So that's what I will type in my box. I'm going to put 0.14 here. We have all of our information. We're going to hit compute, and as you can see, we get a sample size of 100. I also have this in my template. If you look down here, it says sample size for proportion. I'm going to put 0.95. My P was 0.15, and once again we're going to do within. So the number that came after within was 7%. We're going to use that. You do not have to double it, but you do have to change it to a decimal. So that's 0.07, and your answer will populate in this yellow box down here, and it says 99.9563, round up to 100.